Hi everyone, in this video I'll show you how to simplify complex rationals. A complex rational is an expression that looks like this. And yeah, it does look a bit complex, right? But it's actually not as bad as it seems. So let's take it apart and we will conquer this thing. So the way we're going to take this apart and handle it is we're going to focus on the fact that when we have an expression over another expression, this fraction bar is just the same as division. So we can rewrite this as x squared minus x minus 6 over x squared minus 5x minus 14 divided by x squared plus 6x plus 5 over x squared minus 6x minus 7. All right, looking a little more manageable already. Now we use the fact that when we're dividing fractions or dividing rational expressions, we can change this to a multiplication problem. So we keep the first item the way it is, we change this to multiplication, and we flip this expression. In other words, we take the reciprocal. So we keep it, change it, flip it. So we rewrite that. First expression just as is. And then we change this to multiplication, and then we are taking the reciprocal of this expression. So now we have a multiplication problem, but as always when we multiply rationals, we look to see if we can simplify and to see if we can cross-cancel. But before we can do that, we have to factor each expression. So for this first one, that will factor into x minus 3 times x plus 2. And if you have any questions on factoring, just check for my other video on that. In this denominator here, we will have, okay, the factors of 7 and 2 will be the ones that work here. Check that out. And then over here we have this expression factoring into x minus 7 and x plus 1. And our last one factors into x plus 1 and x plus 5. So this is convenient. We do have some things that cancel. The x minus 7s cancel out. The x plus 2s cancel out. The x plus 1s cancel out. And that leaves us with x minus 3 over x plus 5. And that is our final answer. Now here's another complex rational. Now, because we have things being added or subtracted here, we're not going to be able to do the same process we did because we can't just flip everything here over. That plus sign right there is stopping us from doing that. So how do we attack this? What we're going to have to do is multiply everything in the top and everything in the bottom by something that makes all these denominators cancel out. So this one has a factor of x, and so does this one. This denominator has a factor of 1 minus x. This denominator has a factor of 1 plus x. So everything will need to be multiplied by x times 1 minus x times 1 plus x. And we do the same to the bottom. Because recall that if we multiply by something over itself, that's just equal to 1. And so it's not going to change the expression, it's just going to make it in a different form. So one thing I like to do when I'm multiplying like this is write each factor over the things I'm multiplying. It makes it easier to see what's going to cancel. You don't have to do this step if you don't want to, but I will just rewrite it down here and then we'll skip ahead. All right, so now I've got all this rewritten to make it easier to see what will cancel. So here, this factor of 1 minus x cancels with this denominator. This factor of x cancels with this x. This factor of x cancels with that x. And this factor of 1 plus x cancels with that denominator of 1 plus x. So now we've actually gotten rid of all the denominators and we can rewrite our expression. So here we're going to have x times x gives us x squared times 1 plus x plus 1 minus x times 1 plus x times another 1 plus x over, okay, because that takes care of that whole complicated numerator because we got those canceled. And here we're going to have 1 minus x times 1 minus x times 1 plus x, that takes care of all those, plus x squared times 1 minus x. All right, now we can actually do some factoring here. Notice that up here we have a factor of 1 plus x here, and we have another factor of 1 plus x there. So these two terms, this big term here and this even bigger term here, have a 1 plus x. So let's pull that out, 1 plus x. And then what we have left in there is x squared plus 1 minus x times 1 plus x. Actually, let me make this a square bracket since we have some other parentheses nested in there. All right, in our denominator, what do we have in terms of GCF? We have a 1 minus x in this big term and then a 1 minus x here. So that 1 minus x we'll bring out here. And then also we're going to have nested brackets. We have 1 minus x times 1 plus x squared. And notice that because addition and multiplication are commutative properties, that x squared plus this 1 minus x times 1 plus x is the same expression as this factor down here, 1 minus x times 1 plus x squared. So these are the same. So these actually cancel out here and here. And we are left with the answer 1 plus x over 1 minus x. And those are examples of how to simplify complex rationals. If you have any examples you'd like to see worked through on this channel, please leave me a note in the comments. And as always, thanks for watching.